Hey, good morning there, Algebra 2 people. Alright, so now we're on to lesson 1-6. This is the last lesson of the chapter, and it is solving systems by various methods. Hold on, I got to pause a minute. Sorry, just remembered I didn't shut my door and put a sign on not to bother me while I'm recording, so all this weird stuff. Anyway, we're going to be solving systems, and this video is going to focus on the method called elimination. The next video is going to focus on the method called substitution. When you're in Algebra 1, you probably also spent some time what we do call solving by graphing. So let's understand that. I'm not going to solve by graphing in Algebra 2. We're going to go right to the algebraic methods. But let's understand as you look at these three problems that are up here, and there's three more to look at in the video, every equation that's up here is a graph. You could graph this, they're lines now, and that goes back to a few lessons ago where we learned to graph lines in standard form. These problems, as you look at them, they're in standard form, meaning that x and y are on the left side of the equal sign, the numbers on the right side of the equal sign. The x's line up, the plus and minus signs line up, the y's line up, the equal signs line up, and that's important. So understand, if you think of this as, hey, this is two lines that could be graphed together. Think of every problem as two lines that could be graphed together. One of three things happens when two lines are put on one graph. They either intersect in some way, cross this way, cross that way. I mean, it doesn't matter where the lines are, but they are going in different directions where they intersect. The intersection is the solution. It's, in other words, where one equation equals the other equation. It's that one spot that happens. And that one spot is a point. That point is an x and a y. So if we have a situation where the lines cross once, our answer will be an x coordinate and a y coordinate, and it'll be an ordered pair of the location that they cross. Option 2 is the two lines are parallel and never cross each other at all, which means they have nothing in common in terms of points, and that answer would be no solution. That'll come up later. And then you have the situation where the two equations may look slightly different to each other, but if they were graphed, the two lines would fall right on top of each other, which means they're sharing every single point. And since lines go in directions forever, that means there's an infinite amount of times that the lines are touching each other. So those are the three answer options. There's either going to be 1 point, an x and a y coordinate, no points because they're parallel, or infinite amount of points because they're right on top of each other. That's what's going to happen. Okay, now let's get down to the method. We're focusing on elimination today. Here's the deal. At some point in each one of these three problems, we are going to add the two equations together and solve the equation that forms. Here's what we want to happen. When we add the two equations together, we want one of the variables. I don't care if it's x, I don't care if it's y. I want one of the variables to eliminate, cancel in other words. So let's look at number 1. I've kind of set this up in a progression where 1 is friendly and ready to go, 2 requires a little bit of work, and then 3 requires the most work. Number 1, if I add these two equations right now, okay, the x's are 4 plus 1, so 5x. And this next thing is what we're looking for to happen, and if it's not happening, we gotta force it to happen. That's technically 1 plus -1. Y's cancel. There's your elimination. The y's eliminated themselves. Transfer the equal sign down. 2 plus 3 is 5. So the point is to have an equation with one variable in it that we can solve. Folks, if this equation down here has both x and y in it, still, we can't solve it yet. We haven't done our job. So solving for x right here is straightforward. We divide both sides by 5. 5 divided by 5 is 1, 1x. 5 divided by 5 is 1. The fact that we got an answer for a variable means this is a situation where these two lines cross each other if they were graphed. So now my job and your job, plug that x back into either one of these equations and solve it for y, so you have the y partner that goes with this x partner. Folks, you have the choice. Whichever equation looks nicest to you to plug this x in and solve for y, you do. I'm going to choose the top equation. I like the fact that the y's got a plus sign in front of it. I know I'm solving for y. This y has a negative in front of it. I don't like that as much. So we're going to take this equation, which is 4. The x is now 1 plus y equals 2. We're going to multiply this together and solve for y. 4 times 1 is 4, plus y equals 2. To solve for y, I got to subtract 4 from both sides. Y equals 2 minus 4 is negative 2. Folks, we write our answer as an ordered pair, x comma y, 1 comma negative 2. Folks, that means if we were to take the time to graph these two lines on a coordinate plane like we did a few lessons ago, I think it was lesson 1, 2, these two lines would cross each other exactly at the location 1, negative 2. Okay? So you see how that's situated? This is what we're looking for. We're looking for a variable. It doesn't have to be y, it doesn't have to be x, it can be either or. But you're looking for the variables to be exactly the same number but opposite signed. So see how that was exactly 1y and 1y, but this was positive 1 and that was negative 1. That's what I want. So when I look at this next example, the x's and the y's are totally different. Now, when that happens, you are either going to multiply one or both of the equations by a number to force one of the variables to be the same. And understand, this particular example, I have the option to make the x's the same or the y's the same by multiplying one of the equations. I'm going to give you the options, and I'm only going to do one of them. Suppose I want these two x's to be the same number. Now see how this one's 6? It'd be great if that was negative 6. If I multiply the entire equation, both left and right, by 6, 6 times that'll be negative 6x. Yeah, 6 times that'll be something else, and 6 times that'll force that to happen. If I would like, so look at these y's, maybe I want the y to cancel instead. That's negative 12. It would be great if this was something like positive 12. How would I make that positive 12 if I multiplied it by negative 2? So I do have the option to multiply this entire equation, both sides, by negative 2. Because negative 2 times that would be positive 12, and the y's could end up canceling. Now, since I had the y's cancel in the first example, I'm going to focus on the x's this time just to show you that you have the freedom to do whatever. So, I am going to multiply this entire equation, both sides, by 6. Okay? Now I'm going to rewrite the first equation just so things are balanced. So the top equation is 6x minus 12y equals 24. And now I'm going to multiply everything by 6. So 6 times that is negative 6x. 6 times that is negative 36y. And 6 times that's 24. Now I'm ready to add these two equations together. The x's, 6 plus negative 6, cancel. There's our elimination. X is eliminated right now. Our y's are negative 12 plus negative 36. That's negative 48y. And this is 24 plus 24, or 48. We again have one equation with one variable. I can solve that. Divide both sides by negative 48. Negative 48 divided by negative 48 is 1, 1y. 48 divided by negative 48 is negative 1. There's your y value. This time you go back to the beginning, you plug your y value in, you can pick either equation of the original, you go back to the original problem, and plug that y in and solve for x. I'm going to choose the second equation, even though it's got some negatives involved. The numbers are much smaller than the top equation, so that's just my reasoning. So we're going to write negative x minus 6. In place of that y goes negative 1 equals 4. So negative x, that times that is positive 6. It's interpreted as negative 6 times negative 1, a negative times a negative, equals 4. Subtract 6 from both sides. We get negative x equals 4 minus 6, or negative 2. Folks, when you have a negative in front of a x and you're solving, that's the same as saying there's a negative 1 there, which means you need to divide by negative 1. So divide both sides by negative 1. The negative divided by negative is a positive x. Negative 2 divided by negative 1 is a positive 2. And there's your ordered pair. That x, that y, that ordered pair. If these two lines are graphed on the same graph together, that's exactly where they cross. 2 to the right, 1 down. Okay, moving on to the last example. This example is the most challenging of the three because the two variables, first of all, neither one of them is ready to eliminate. If I add together, the x's don't cancel. If I add together, the y's don't cancel. I can't easily just multiply this 2 by something that becomes a 7. I can't multiply this 3 by something easily that becomes a 10. So this comes to me having to multiply both equations by a select number to make that happen. This time I'm going to make, just because it's in the beginning and I'm going to do the x's. What I commonly do right here, to address all students and say sometimes this is difficult for us, it's very easy just to swap the two numbers and that's your multiplier. So see how this is 7 and negative 2? Swap them and multiply by 2 and 7. Now, be very careful. This can be confusing. My x's are already opposite in sign, and that's what I want. I always want, see, 1 positive, 1 negative. That's how they cancel when I add. 1 positive, 1 negative. I don't want to create a sign change, which means use two positive numbers as your multiplier. So I am going to multiply this all by 2 and this one all by 7. Focus on your x's a minute, even though I got to multiply the entire equations. Look at your x's. That times that is 14. That times that is negative 14. That's what I want. That's what you need to happen. Okay, so the top equation becomes 14x plus 20y. So you have to multiply everything by 2. 2 times that, negative 36. 7 times that, negative 14x. 7 times that, minus 21y. 7 times that, 42. Add these two equations together. I don't know why I like to have that circle, just to kind of focus there. Okay, so if I add these two together, 14 plus negative 14 cancels. There's your elimination. X's have been eliminated. 20 plus negative 21 is negative 1y. And negative 36 plus 42 is 6. I don't care if I wrote that as negative 1y or just negative y. It's just like this step right here. Divide both sides by negative 1. Negative 1 divided by negative 1 is positive 1. That's 1y. And 6 divided by negative 1 is negative 6. There's your y coordinate. Take your pick, plug this back in, solve for x. I'm going to take the top one. The numbers are bigger, but they're a little more positive in terms of the x and the y, and I like that. So, and just kind of showing you that it just doesn't really matter. Pick either equation is fine. So I'm going to take the top one, which is 7x plus 10 in place of that y, negative 6 equals negative 18. And solve this out. 7x, that times that is negative 60 equals negative 18. I got to add 60 and divide by 7. We've done this solving earlier. So add 60. That cancels. 7x equals, what, 42? Negative 18 plus 60, positive 42. Divide both sides by 7. 7 divided by 7 is 1, 1x, and 42 divided by 7 is 6. We have an ordered pair of 6 comma negative 6. X then y, x then y. So far you've seen 3 examples where if the lines were graphed, they would have crossed. I know they would have crossed because I got a solution for x and y for each one of these, and that's what that means. So that's the first 3. Now I have 3 more. I'm going to pause a minute and get that ready. Okay guys, so here's the next and final 3 of the elimination method. That's going to end this video, and the other video is going to contain the substitution method. So let's just pick up where we left off. So this next one here. Again, please notice elimination makes the best sense when everything's in standard form and lining up, and everything is in standard form and lining up, meaning the x's line up, the plus minus, the y, the equal, the number. So here we go. Now I just want to talk options here a minute, and I may get a calculator out because the numbers may get big in this example. 1, if I want to just take a completely straightforward and not have to stress about this a lot, when I look at these two, say I wanted to eliminate the x's. This is 11 and 10. Yes, it's negative 11 and negative 10. I could choose to multiply this by 10 and 11. Please notice, I would have to make one of those numbers negative because I want the signs to be opposite. So if I just multiply them by 10 and 11, they both still be negative. So I might multiply this by negative 10 and this equation by 11, creating the sign change. Maybe I want to delete the y's, eliminate the y's. You could take an easy route of, now here, we're in the same boat. They're both negative right now. To alternate the sign, I'd have to make one number negative in my multiply. So if this is 4 and 10, I could do 10 and 4. Making one of them negative, like negative 10 and 4. Or 10 and negative 4. And here's the final option, and then I'm going to go back and take my x option just because I think it's the easiest and least stress. Do you understand that I wouldn't have had to choose 10 and 4? Like if I multiply by 10 and 4, 10 makes that a 40, multiplying by 4 makes, I could make those 40 and negative 40. I could have multiplied this one by 5 and this one by 2. That's because these numbers can be made into something smaller than 40, and that's 20. Times 5 makes that 20. Times 2 makes that 20. If you see that and have the insight to say, hey, I could use smaller numbers like that, go for it. But at the same, you have to understand, you have 3 options that all work fine, and there's probably others, of course. But those are 3 options that work just fine. I'm going to take the option that's probably least favorable just to show you it works anyway. I'm going to do the x version of alternating and using the 10 and the 11. So, I'm going to multiply everything in this equation by 10, everything in this equation by 11. Now please understand, I have to make one of those negative. Okay? Because right now, as it stands, if I multiply one of these together, 10 times 11 is 110, right? 10 times 11, 110. Well, that times that's negative 110. That times that's negative 110. I don't want them both negative 110. So I need to pick one of them to be the negative number. It doesn't matter, I'm just going to make it that. So here we go, people. Negative 10 times negative 11 is 110x positive. Negative 10 times minus 4 is positive 40. And negative 10 times 36 is negative 360. We have to be very careful in our multiplication and very careful in our sign. Hopefully, as I say that, I don't make a dumb mistake in front of you all. It's happened. 11 times all of these. 11 times this is negative 110x. 11 times that is negative 110y. And 11 times 20 is 220. And now we're going to add these two equations together. So 110 plus negative 110 cancels. There's our elimination. 40 plus negative 110 is negative 70y. Negative 360 plus 220 is negative 140. See, it doesn't matter that these numbers are rather large, people. You can add things in your head and on a calculator, however it works for you. This is all okay. Divide both sides by negative 70 because I have something that's straightforward to solve for me. Negative 70 divided by negative 70 is positive 1y. Negative 140 divided by negative 70 is positive 2. So all that kind of big number worked into something rather reasonable. Take that 2, plug it back into the y position of your choice. I'm taking the top equation. I like those numbers better for some reason. Don't have to have a good reason, just wherever you feel like it. Okay? So folks, that's a negative 11y, or x, excuse me, minus 4 times 2 equals 36. That's negative 11x minus 4 times 2 is minus 8 equals 36. We're going to add 8. Negative 11x equals 36 plus 8, which is 44. Divide both sides by negative 11. Negative 11 divided by negative 11 is positive 1, 1x. And 44 divided by negative 11 is negative 4. So we have another ordered pair where everything, obviously this means everything crosses each other, and it crosses exactly at negative 4 too. So please understand, I kind of chose the biggest number version of solving this. So what some people would say the most complicated version, all worked out, right? Okay, moving along. This one we're kind of in the same boat. I'm not going to go over all solving options. I'm just going to take what I consider the fastest, easiest road. The x's are already opposite signed. I like that. This is 2 and 5, so I'm going to go times 5 times 2. And I'm just going to kind of double check and make sure I got everything set. That's going to give me a 10x. That's going to give me a negative 10x. That's what I want. 10 and negative 10. I want that opposite. We're good. So top equation, 5 times 2, that's 10x. 5 times 8 is plus 40y. And 5 times 6 is 30. This times that is negative 10x. This times that is minus 40y. You can start to look right now, something weird's happening. They both ended up opposite. And then 2 times that is negative 30. When I add this up, 10 plus negative 10 eliminated, which was my original goal, eliminate the x's, but 40 plus negative 40 eliminated. Folks, I must write a 0 on that side. Your whole side cancels, you got to put a 0 there. You have an equation, you start with an equation, you end with an equation, which means a left and a right. And then 30 plus negative 30 is 0. Okay, all variables canceled. I don't have an x equals or a y equals. What's going on here? Well, here's the deal. That's a true statement. 0 does equal 0. The fact that it's a true statement means that this is one of those graphs where if I do graph these two lines, they fall right on top of each other. They're right dead on top of each other, meaning they share infinitely many points. That is the answer. We write infinite solutions. because they cross in so many places that you can't document them all. Okay? So, there is that situation. That's what a set of same lines falling on top. And you can look at those original equations, look different to each other. 2x plus 8y equals 6, and negative 5x minus 20y equals negative 15. That's different. But they would have had the same x-intercept, the same y-intercept, the same slope, and they land right on top of each other. Okay, next option, we're kind of taking the same route. Now this one, I am going to take a slightly different route in terms of I quickly see this 3, if I multiply it by 4, can become 12. So I see that right away. Now please understand, I can't just multiply it by 4. It's got to be negative 4. I need opposite signs with my x's if I choose my x's to eliminate, which I am. It's the most common choice by students. That times that would be 12. That is negative 12. That's what I want. Okay, so top equation, negative 4 times that becomes 12x. Negative 4 times that becomes minus 16y. And negative 4 times that becomes negative 12. I'm not doing anything to this equation because I didn't have to. That just stays negative 12x plus 16y equals 8. Ready to add, and we can see something similar is happening, but it's going to be different. We do see that 12 plus negative 12 eliminates, which was our original goal. However, negative 16 plus 16 also eliminates. We're in that situation where you have a 0 on that left-hand side instead of an x or a y left over, everything eliminated. Over here, however, negative 12 plus 8 is negative 4. Now, what's the difference between these two problems? Because over there, the x and y canceled and eliminated also. That's a true statement. 0 does equal 0. That's a false statement. 0 does not equal negative 4, meaning this is not a reasonable situation. What's this mean? These two lines are parallel. They don't cross. They have nothing in common. They never touch each other, so they don't have any points to say that they share. So we say no solution. So that covers the elimination method and the options. And you do understand both infinite solutions and no solutions share the deal that the x's and y's end up eliminating themselves sometimes unexpectedly, but it comes down to, is the statement true or false? If the statement's true, which means, hey, this is happening, lots of answers, infinite. That's not true, makes no sense, not happening, no solution. Parallel lines, same line. All right, that's the end of this video. Just under the time limit, folks, all right? Take care.